This is the second assignment based on algebra. Let's look at the first question. It says list all the factors of 5 times x times x. So there are a few factors here. I'll go through them. The obvious factor is 1. 1 is always a factor. So 1 is a factor of 5 times x times x. 5 is a factor of 5 times x times x. You can see that because 5 is in the product, 5 times x times x, so 5 is a factor of 5 times x times x. Similarly, x is a factor for the same reason. Now we can write down factors with their factor pairs. So for example, x squared pairs with 5 to make 5 times x times x. So x squared is a factor pair with 5, and it's a factor of 5 times x times x. Similarly, 5x is a factor of 5 times x, and that pairs with x. And the whole, all the factors in the product, 5x squared, or 5 times x, is also a factor of 5 times x. And notice that if we multiply these factor pairs together, we get the expression 5 times x. We could also think about these as areas. If the area of a rectangle is 5 times x, then we can draw it as rectangles with different heights and widths. In this first example, we could have a height of 1 and a width of 5 times x, or 5x squared, and that would have an area of 5 times x. For this term, we could have a height of 5 and a width of x squared. The area of this rectangle would be 5x squared as well. And finally, we could have a height of x and a width of 5x, and the area is the same. So there are 6 factors for the term 5x squared, and they are listed there. Okay, the like terms here. Terms are like when they're in the product, you have exactly the same letters. Okay, so if we look at when the letters are exactly the same, we have x times x in this 2 times x times x. Here we have another x times x, but it's negative, so we have negative x squared. This is negative x times x. And in the final term, we have x times 3 times x, so this is also a like term. The other 2 terms that are listed are not like because the letters are different. We could write these next to each other, and we'll combine the 2 x's in this first term to make it x squared, because it's x times x, which is x squared. There are 2 of them. We can have negative x squared for that second term, and using the commutative law of multiplication, we could write this in a different order, and this becomes 3x squared. Okay, these are like because the letters there are exactly the same. We have x times x in each term, and we can combine them, which means collect the like terms or add them together. So if we have 2x squareds minus an x squared, and then plus the 3x squared, we'll get 4x squared overall. I'll do that in 2 steps. 2x squared minus the x squared would give us 1x squared, and then we could add the 3x squared. The 3x squared plus the x squared will give us a 4x squared. Another way to think about this would be, again, with an area model. So we could draw these as 3 rectangles with the same height. So we could have the first rectangle having a height of x squared and a width of 2. The second rectangle, would have a height of x squared and a width of 3, perhaps. And then the final one, well, we would take off 1 from the width, because it's a negative x squared. So what is the total area of this rectangle now? Well, before we did the subtraction, it was 5x squared. Then we subtracted the 1x squared to give us overall 4 lots of x squared. So the area of this green shaded region is 4x squared. Okay, nice. Let's look at the next question. So it says, write down an expression for the area of the rectangle as a product of its height and its length. So notice how we have one large rectangle that's been split in 2 along its width. Okay, so the total width here is 2x plus 3. So the area for the whole rectangle is going to be its height times by its width, which is going to be 3xv times by 2x plus 3. You don't need to write that times sign, you could just write it like this. Okay, so an area of a rectangle is just its height times its width, and it's about understanding that the total width of this rectangle is 2x plus 3. And so we can write it like this. Hey, question 4. Draw the expression 8 times a times a times b plus 20a times b as the area of two rectangles stacked together with a common height. So you can do this in various ways. I'll look at a couple of them now. Okay, so to begin with, I'm going to underline the common factors, or some common factors between the two terms. Here I've underlined a times b and a times b in both terms, and this is a common factor. So we could create two rectangles where the height was a times b, or ab. If the height of the first rectangle is ab, then its width must be 8a, so that its area is 8aab. Similarly, the width of the second rectangle must be 20b to make the area 20abb. So here we have drawn the expression as the area of two rectangles stacked together with a common height. Another way to think about this, or to factorise more fully, to take up more common factors, would be to rewrite the expression as something like this. We've broken up the 8 into 2 times 4 and the 20 into 5 times 4. So now we can underline the common factors. The common factors would be 4 times a times b and 4 times a times b. Okay, so we've done this because then we can take out a higher common factor than we did in the first example. So in the first example, we did not fully factorise, and we're about to fully factorise by taking out the highest common factor, which is 4 times a times b. The height would be 4 times a times b. The width of the first rectangle would therefore be 2a, and the width of the second rectangle would be 5b. So this, if I were to write it in its factorised form, would be 4ab brackets 2a plus 5b, similar to the above example, question 3. And the first example that we've looked at here, if we write it in factorised form, would be ab brackets 8a plus 20b. If we go back to example 3, notice that I could have written this in expanded form, which would be to write down the areas of both rectangles separately. To do this, I could say, well, what's the area of this first rectangle? Well, this would be 2x times 3xv, or using commutative law, 2 times 3 times x times v. And combining things in this product, we could have 6x squared v in its most simple form. Similarly, the second rectangle is 3 times 3 times x times v, which would be 9xv when you simplify. So if we write this in expanded form, it would be 6x squared v plus 9xv. And you could see this using brackets rather than an area model by doing this 3xv times by the 2x and this 3xv times by the 3. And that will give you 6x squared v and 9xv respectively. Let's move on. Okay, so this is a question about expanding and simplifying. So expanding means write the expression without brackets, and then simplifying in this question means collect the like terms or combine the like terms. So to begin with, let's rewrite negative as -1 times by this bracket. This will help us to see what's going on when we expand it. Similarly, I'm just going to write it as plus 3 lots of this next bracket. We'll expand using an area model, but you don't necessarily need to. I can split this area into 3 separate rectangles. It has a height of -1 and a width of 2x, -3y, and plus 1. This rectangle will have a height of 3 and widths of x, -2y, and plus 7. If I write down the areas of each rectangle, we have -2x because it's -1 times 2x. We have positive 3y because it's -1 times -3y. And we have -1 because it's -1 times positive 1. In this rectangle, we have 3 times x, so it's 3x. We have -6y, and then plus 21. We can write these terms separately. So we have -2x plus 3y, subtract, or add -1. So I've written these terms here. Then adding 3x, we can think about adding -6y and adding 21. Now, some of these plus signs are redundant. You don't necessarily need them, but it can be helpful to write all the positive signs in, because then later we can rearrange this as addition. We can write it as -2x plus 3x. we could write it as plus 3y plus negative 6y, and plus negative 1 plus 21. So I've just moved the terms here, where the terms are negative 2x, 3y, negative 1, 3x, negative 6y, and 21. I can combine these or collect these terms to get 1x there. 3y plus negative 6y is negative 3y, and then negative 1 plus 21 is obviously plus 20. So that is the simplified version, or the expanded and simplified version. So there are now no brackets, and I've collected the like terms. Okay, let's look at another question. So it says, using rectangles, explain why 3 times a is not a like term with 2 times a times b. Now, these are not like terms because in like terms you must have the letters exactly the same. To explain this using rectangles, maybe isn't that obvious, but what you would need to do is, say, create a rectangle where the height perhaps is the number and the width is the letters that you have in the term. We could do this for the second term as well. We have the height, which is the number 2, and the width, which is a times b. Now, because we have different widths here, we cannot draw these two rectangles as one large rectangle because, you know, the heights, the widths are different. So the rectangles, basically, they can't be stacked to form a large rectangle. And stacked means turn them into a large rectangle, I guess, to form one large rectangle. Okay, so that's that question. Let's look at the next question. So this guy, Dustin, believes that negative brackets 2a minus 3b plus 4 can be written without brackets as the following expression. So he's basically expanded this bracket and he's come up with this expression that doesn't have brackets. Is he correct or not? And so he's not correct. And one way to explain it is to again write the negative sign as negative 1 times by this bracket. You could use an area model if you wanted, or we can do this method where we do negative 1 times the first term, negative 1 times the second term, and negative 1 times by the third term. I'll draw this as an area as well, just for completeness. So the width of the first rectangle will be 2a, then negative 3b, and then positive 4. The areas are negative 2a for negative 1 times 2a, negative 1 times negative 3b is positive 3b, and then negative 1 times 4 is negative 4. So when you add these terms together, you get negative 2a plus 3b, subtract 4. So Dustin is wrong. Okay, I'll move on to the next question. So it says we can draw the expression 35ef squared plus 14ef in the following way. Explain why the expression is not fully factorised. So fully factorised is the key idea here. So it has been factorised because we've taken a common factor e out of the two terms and written it as a rectangle, two rectangles with a common height of e. Is it fully factorised? Well, that really means, have we taken out the highest common factor from both terms, or have we made the rectangle as high as possible, I guess? So we haven't, and let's write down a quick definition for fully factorise. Have we stacked the highest possible rectangles? So that just confirms what I've said. And in this case, so we have to use the highest common factor, the HCF, as the height, okay? So let's rewrite the original question, 35ef squared plus 14ef, and let's write it with more factors in the product. So here we have 35 times e times f, but why not split it into its primes, so 5 times 7, and then times e times f times f. This way we can see all the factors that go into that term. Similarly, here in this term we have 2 times 7 times e times f. So we can see that the highest common factor will include a 7, an e, and an f. That's the highest common factor of both terms. So this must be the height of the rectangle. So we could draw it as 7ef, and then the widths would have to be 5f and 2. So factorised, written with brackets, would be 7ef brackets 5f plus 2. I'll go back. So this expression, 7EF brackets 5F plus 2, is fully factorised because I've written it, I've taken out the highest common factor or stacked it as two rectangles using the highest possible height, which is the highest common factor of the two terms. Okay, let's move on. So this is a question about adding terms that are like that include fractions. Okay, so firstly I'm just going to rewrite this, but I'm going to change the final term there. So we've got a half p plus a 6q, subtract 3/5 of p, and then I can write the final term as 2/3 of q. So I'll just rewrite that with the final term changed. Or I'm not going to change it yet. I'll rearrange. So we have a half p subtract 3/5 of p. So I've moved the term there, which is negative 3/5 of p. And then I'll write this final term as 2/3 of q rather than 2q over 3. And just to check you agree that I can do that 2q over 3 is indeed 2/3 of q. So 2/3 q we could think of as being 2/3 times by q, which is the same as 2/3 times q over 1. And 2/3 times q over 1, well, we multiply the numerators, which is 2q, and the denominators, which gives us 3. So 2/3 of q is indeed the same as 2q over 3. It's similar to timesing a whole number by a fraction. So we're going to need to collect the like terms. We cannot collect these like terms because to add fractions, we need the denominators to be the same. So the lowest common denominator of 2 and 5 is going to be 10. So we can write these as tenths. A half is the same as 5/10, multiply the numerator and denominator by 5. And then 3/5 is going to be the same as 6/10, multiply the numerator and denominator by 2. For the final two terms, the lowest common denominator is going to be 6ths. So a 1/6 of q stays the same. And then 2/3 of q is going to change to 4/6, timesing the numerator and denominator by 2. Okay, so we need equivalent fractions in order to add the fractions. Adding the fractions, so 5/10 of p minus 6/10 of p is going to be negative 1/10 of p. And then 1/6 of q plus 4/6 of q is obviously 5/6 of q. Just go back. So in this question, we have rearranged the expression. We've written 2q over 3 as 2/3 of q. And we have used equivalent fractions to add the terms together. Okay, moving on. I'm going to use an area model to expand this, but you don't necessarily need to use one. So for the first bracket, I will have a height of 2/5 and widths of a, 2b, and negative 5c. For the second rectangle, the height is negative 1/3, and the widths are going to be 4a, minus b, and then 6c. Now, a mistake in this question would not to include that negative for the negative 1/3. It must be negative 1/3 as the height. Okay, we can write the areas in. So 2/5 times a is 2/5 of a. 2/5 times b, well, we can do the 2 times the 2/5 to give us 4/5 of b. And then 2/5 times negative 5c, I'll just go back to this one quickly, just to convince you. So 2/5 times by 2b is 2/5 times 2 times b, and 2 is 2 over 1, so this becomes 4/5 of b. Okay, so that's a way to convince you that this is indeed the case. Negative 5c times 2/5 of c is going to be negative 10/5 of c, and we could simplify that to be negative 10/5 is the same as negative 2, because 10 divided by 5 is 2. So we could write that as negative 2c. For this area, we get negative 4/3 of a. Negative 1/3 times negative b. I'll just write this again. So negative 1/3 times by 4 times a. We times the numerators to give us negative 4 over 3, lots of a. Okay, so that's convincing you again, reminding you how to times a whole number by a fraction. For this term, we'll get positive 1/3 of b, because we've got negative 1/3 times negative b, which we could think of as negative 1/3 times negative 1 times b. Negative 1/3 times negative 1 is positive 1/3 of b. And negative 1/3 times by 6c is going to be negative 6/3 of c, which we could simplify as negative 2c. Okay, so you don't need to write all of these steps necessarily. I'm just writing them in detail so you can see how all these ideas fit together. Okay, so this term is 2/5 of a. This term is 4/5 of b, and subtract 2c. This term here gives us negative 4/3 of a, plus 1/3 of b, subtract 2c. We're going to rearrange the terms, writing the like terms next to each other. So 2/5 of a, subtract 4/3 of a, and then add 4/5 of b and 1/3 of b, and then subtract 2c and 2c. So negative 2c, subtract 2c. Okay, we'll combine these terms, but we can't combine them because the denominators are not the same, so we must write the denominators, the lowest common denominators. So 5 and 3 gives us 15 as the lowest common denominator. And so 2/5 is going to be the same as 6/15 times the top and bottom by 3, times the top and bottom by 5 here gives us negative 20/15. 15ths for these two terms again. So we know this is going to be 12/15 times the top and bottom by 3, and then 5/15 times the top, the numerator and denominator by 5. And we don't need to do anything with these two terms. We can just write it as negative 4c. We can now add these terms in a and b. So 6/15 minus 20/15. Be very careful here. It's a common mistake to write 26/15 or negative 26/15. It should be, if you've got 6/15 and you subtract 20/15, you're going to get to 14/15. And then this one's obviously more obvious. 12/15 plus 5/15 of b is going to be 17/15 of b. And negative 4c doesn't change. So that's that question. You don't necessarily need to draw the rectangles if you don't want to. You could use the arrow notation to do 2/5 times by the a, 2/5 times by the 2b, and 2/5 times by the negative 5c to start the question. But it's really important that you have negative 1/3 times by each term in that bracket. So negative 1/3, not including that as a common mistake. Okay, the final question here, a really challenging question. To begin with, we could draw, if we wanted to, this as the area of two rectangles stacked together. If we do the expansion here, we're going to get 16x to the 4y squared, and then 8x cubed y. Now I'm going to rewrite these, and then I'm going to write them, breaking them down into the primes. So 16 is 2 times 2 times 2 times 2, and then x to the 4, we're going to have x times x times x times x, and then y squared is y times y. The second term, 8 is 2 times 2 times 2, x cubed is x times x times x, and then y on its own. Oh, let's go back a bit. Okay, so what I'll do is I will rearrange, using the commutative law of multiplication, the factors within the first product. So I'm going to write 2 times 2 times x times y, and then I've got the extra two 2's, the x times x, and an extra y. Okay, so notice how I've written it as two. I've written this as two groups within this product. Each group has exactly the same factors. Okay, and I will just rearrange this slightly to look more like one of the groups from the first term. Okay, so you can see there, that's the same group as in the first term. So if I've written the first term as two groups multiplied together, this is the same, or this is really a square. It's got the same height and the same width. Okay, so the height of this rectangle, this square, is going to be the same as its width. Okay. And then, since the height is 2 times 2 times x times y, the width of the second rectangle must just be 2 times x. Okay. So you can see I've also written 2 times 2 times x times y is just 4x squared y. This here is the square that I was talking about. And so it says draw the image below that best represents this situation. And here we have drawn the situation. The question said, can you draw it as an area of a square and a rectangle that share the same height? And that's exactly what we've done. Okay, so a very challenging question, mostly because the language is difficult.